Hi folks, welcome to part 2 of lesson 2. So we're just going to do a couple of examples where we're actually going to calculate the sum and differences of vectors. So first of all, we'll notice that the vectors are given using the cardinal directions. All right, and we're being asked to subtract these two vectors. So given that these vectors are given explicitly with their own magnitudes, their own directions, what I'm going to do is instead of doing this subtraction, I'm going to think of this as adding the opposite of the second vector. Okay, so that means we have to determine what the opposite of this vector is. So you're going to notice that when I draw a vector that's given in this form, I always start off by drawing a little cardinal plane at the tail of the vector. And so from here, if I want to do 20 north, 10 degrees east, so it means that my direction starts at north. So remember, north, east, south, west. Okay, and it's going to move 10 degrees towards the east direction. So this vector looks something like this, where this angle here is 10 degrees. Now you'll notice that I'm not measuring anything with rulers because the diagram is just going to be a guide. All right, so if I want to add these two vectors, I'm going to add them tip to tail. So first I'm going to draw vector u. Okay, so let me create my little cardinal plane here. So vector u is 30 east 20 degrees north, so east 20 degrees towards the north. So there's my vector u. Okay, this is 20 degrees. The magnitude is equal to 30. And now I'm going to add to that the opposite of v. So let's figure out what the opposite of v is. But we're going to see it's very easy to do because I want a vector that's in that direction. So you notice that it's just going to be inverting these two directions. It's just going to be south 10 degrees west. Okay, so in order to draw my second vector, which again tip to tail, so the tail of my second vector is going to start here, I'm going to draw myself another little cardinal plane at that point. Okay, and what did we say? It was south 10 degrees west. So it's going to look something like this, and I'll make an effort to make it a little shorter than that one there, just so that diagram looks reasonable. And in this case here, my magnitude is 20. Okay, and so the resultant is going to be the vector from the tail of the first to the tip of the second. Okay, so this is going to be the vector u minus v. And what we notice here is that I've got a triangle that's formed. So the way I'm going to solve this problem is just by using good old trigonometry. So I'm looking for, let's start off with the magnitude, the side length of this triangle here, which represents the magnitude of u minus v, and I know the other two sides. So if I can find one of the angles, I can use either sine law or cosine law. So let's figure out if we can find an angle. So this is where I notice here that this angle 20, this east-west is parallel to that east-west, so this angle 20 is going to be the same as that angle there, which is also going to be 20. And this is a right angle, so this angle inside the triangle is just going to be 90 minus 20 minus 10. 90 minus 30 is just 60. And this is where you see how we're using our basic geometry principles. Okay, so alternate interior angles. All right, we also have complementary angles. You might be using supplementary angles. So all those basic geometry rules are going to come into play. So now I have enough information to use, well, cosine law to solve this problem. So if I want to find the magnitude of u minus v, okay, that's just going to be the square root of, so it's just going to be the square of the other two sides. So 30 squared plus 20 squared minus 2 times 30 times 20 times the cosine of the opposite angle, which is 60 degrees. Okay, so let's calculate that here. Okay, and make sure you're using your calculator correctly. So it's the square root of 30 squared plus 20 squared minus 2 times 30 times 20 times cosine of 60 degrees. and we get 26.5 units. All right, since they didn't specify the units, we'll just leave it open-ended. All right, now we need to find a way to determine the direction of this vector. But notice that this vector starts at this cardinal plane. So if I could figure out what this little angle is, I could just say it's east, that angle towards the south. But of course, this little angle here is not in the triangle, but what is in the triangle is that angle there. All right. So if I find theta, I can just subtract 20 to get the angle that I'm looking for. Okay, so in order to find theta, since I know all three sides, I'm going to use cosine law. Okay, now think about why I'm using the cosine law and not the sine law. All right, there's a very good reason why I'm doing that. So it's going to be cos inverse. Okay, and let's think about how the cosine law works. So if I want to isolate the angle, I have to bring these two things to the other side. So it's going to be the opposite side, 20 squared, and I'm taking the other two sides to the other side, so minus 30 squared minus 26.5 squared, and then I'm going to be dividing by this coefficient in front, which is negative 2 times 30 times 26.5. Okay, and let's calculate that angle. Okay, now again, make sure you're being very careful with your use of brackets. So it's going to be cos inverse of, don't forget to open brackets for the numerator, 20 squared minus 30 squared minus 26.5 squared. Close the bracket, divide, open up another bracket for the denominator, negative 2 times 30 times 26.5, and that gives us about 41 degrees. Okay. So 41 degrees. But remember, what we're looking for is this angle here. Okay, so I'm going to subtract 20. That's going to give me 21 degrees. So my final answer, U minus V, is going to be equal to my magnitude, 26.5, and then it's going to be east, 21 degrees south. Right? Now, some of you may have seen when this is given, there's square brackets around there. You can certainly keep using that. That's perfectly acceptable. Sometimes I might use it. All right. So what did we do here is we use the tip to tail method because the vectors were given explicitly. It was easy to draw each vector. Whereas you're going to see me take a different approach in the second example, because take a look at how these vectors are given. We're given the magnitudes explicitly, and then they give us the angle between the two vectors. And this is where we remember that the angle between the two vectors is when those vectors are placed tail to tail. So if this is my vector with magnitude 4, and I can write it in any way I like, might as well draw it horizontally. And then I know that my second vector, the longer one with magnitude 7, is here, and there's an angle of 40 degrees between them. All right. Now, I guess I could draw my parallelogram here, but I think it's just easy to take this vector 7 and just move it, as I'm allowed to, across so that it's tip to tail with that first vector. Okay, so let's take this vector with magnitude 7, the vector v, and just move it along there. And now I can add these two vectors tip to tail, so my resultant vector is going to be from the tail of the first to the tip of the second. So this is going to be u plus v. But this is where you need to be careful, because this angle of 40 degrees is nowhere inside this triangle. Okay? What is inside this triangle, though, is this angle here. And again, remember, as I moved 7, it has the same direction, meaning these two vectors are parallel. So now we can use, again, our parallel line principle that says that if I've got two parallel lines with a third one crossing them, that the acute angle and the obtuse angle are supplementary to each other. If you don't see it, just extend that here. This is also going to be 40, so this is going to be 180 minus 40, so 140 degrees. So this is the angle that's actually inside the triangle. Okay, so make sure you keep track of that. So if I'm looking for u plus v, well, again, I know the other two sides. I know the opposite angle, so I'm going to use cosine law again. All right. So 4 squared plus 7 squared minus 2 times 4, 7 times cosine of 140 degrees. Okay, and let's see what we get here. Square root of 16 plus 49 minus 2 times 4 times 7 times cos of 140. And we get, looks like it's 10.38. Okay, so let's take a look here. We'll just say 10.4. Okay, all right, so now let's find the angle. Okay, now how are we going to describe this vector here? Because we don't have a north, south, east, west to work with. So what I'm going to do is I'm going to find this angle here, and I'm going to say, well, it's this many degrees from vector u towards vector v. All right, that's how I'm going to describe the direction. So we need to be a little, need to sort of think outside the box as to how we're going to describe the direction, because everything is given with respect to the position of the two angles. All right, so let's start by finding this angle theta. And again, I'm going to use the cosine law. So cos inverse of, so what do we have? Its opposite side is 7, so it's going to be 7 squared minus 4 squared minus 10.4 squared, all over negative 2 times 4 times 10.4. All right, so let's calculate that here. So inverse cosine, open the bracket for the top, so 49 minus 16 minus 10.4 squared. Okay, and then divide by, in fact, I'm not 100% sure I opened the other bracket. Yes, I did. If you're unsure, I'd say it's worth going to check. So negative 2 times 4 times 10.4, and we get, looks like it's 25, about 25 degrees. All right, and so here we can give our final answer that u plus v is equal to a magnitude of 10.4, and the way I'm going to write this is I'm going to say 25 degrees from vector u toward vector v. Okay, from u towards v, 25 degrees. All right, so before we move on, did you figure out why I use the cosine law instead of the sine law? Well, it's because of this. If I were to use the sine law, I would have had to use two sides and one angle. All right, because I only had one angle inside the triangle. Same thing here. And the problem with two sides and one angle is you have the possibility of running into the ambiguous case of the sine law. So I could go through the process to check, and depending on my diagram, figure out what angle I wanted, but why do all that if I can avoid it by just using the cosine law? So the big suggestion is, if you have the ability to use cosine law to find an angle, I would strongly suggest using that as opposed to the sine law, so that you never have to worry about that old ambiguous case. All right, that's it for this one.